Hey all! So last lesson we talked about stoichiometry. So let's one up and look at stoichiometry. But this time, oh my goodness, I'm given 1 grams of sodium, I'm given 1 gram of oxygen, and I want to know how many grams of sodium oxide am I gonna get. Now you may be thinking, yo, yesterday you said something about, or the other lesson, what am I talking about yesterday? That law of conservation of mass says that the sum of the reactants equal to the sum of the products. So, hey, 1 gram plus 1 gram, 2 gram, booyah! If that's the case, lesson's over. I mean, done. But of course that's not how it works. Yes, 1 plus 1 is 2. Like, who doesn't know that? But you have to think. One of these maybe are given too much. Right? When we say that there is a reagent that is given too much, we say that reagent is in excess. Excess reagent. And the one that is given just enough, it's called limited. Okay? So it's not 1 plus 1, obviously. This is not 2. I can tell you right now, it's not 2 grams. You'll be surprised exactly how much of this. Well, for sure, you do know that it's going to be less than 2. I mean, you're not going to be magically making mass, are you? It's going to be less than 2. But how much less? That's my ultimate question. So that brings me, of course, to this lesson, limited and excess reagent. So when you are given both reactants, we are not assuming that one of them is unlimited anymore, because last time we were assuming that oxygen was unlimited. Not no more. There's only 1 gram of this, okay, and 1 gram of these. We need to know which one is limited and which one is excess, because we need to use the limited one to find the product. So this is how you're going to do it, by convention. Okay? There's actually many ways of doing this, but this is the way that I would say is by... There's a reason to it. So let's do this. Let's do this. So let me start. The starting point is pick one of these. Okay? I would say I pick this one. What do you mean by pick one of these? Well, I want to know, if I have 1 grams of sodium, how much oxygen do I need at least for this reaction to go to completion? Let me say that again. If I have 1 gram of sodium, how much oxygen do I need at least for my reaction to go to completion? And I'm going to compare that number to this. So let's do that. Let's do that. So what I need to do here is I want to know how much oxygen is required if I were to react all 1 grams of sodium. So 1 grams of sodium times 1 mole over 23. So remember, you're going to have to change that to moles because it wouldn't make any sense, okay? Because the second step right here is based on mole ratio of 4:1. Because for every 4 moles of sodium, you need 1 mole of oxygen gas. Grams and grams cancel. Sodium and sodium cancel. Here, moles and moles cancel. And what you have here now is mole of O2. Well, let's turn that into mass of O2. So therefore, I can make that comparison because what I'm given here is mass. So that's easy. For every mole is 32 grams. So moles and moles cancel. And what I have now is grams of O2 That's exactly what I want as a comparison point, right? So 1 divided by 23 divided by 4 times 32. And that would be 0.35 grams of O2. So let's do a midway, I don't know, conclusion or therefore, if I have 1 grams of sodium, I need at least 0.35 grams of oxygen for this reaction to go to completion. Let me say that again. If I have 1 grams of sodium, I need at least 0.35 grams of oxygen for this reaction to go to completion. Well, am I given more or am I given less of O2? Check this out. I'm given 1 grams of oxygen. If I were to react 1 grams of this, all I need is 0.35 grams of oxygen. But I'm given 1 gram. I'm given too much oxygen. What do you mean by too much? That means 1 grams of oxygen is the excess reagent. That's excess reagent. Which means sodium in this case is the limited reagent. Okay? That will be the limited reagent. Because 1 grams of sodium requires only 0.35 grams of oxygen. But I'm given 1 grams of oxygen. That means I'm given too much oxygen. Too much excess. Which means the other reactants will be limited. Now, let me do this again. Okay? This time, I'm going to use oxygen as my starting point. Okay? So, with 1 grams of oxygen, how much sodium do I need? So, this is the one that I'm going to put a question mark on. Because I want to see if it's still limited. So let's do that. So 1 grams of oxygen. How much sodium do I need? Okay, all right. That's easy. Let's change mass of oxygen to mole of oxygen. For every mole of oxygen, you're going to need 4 moles of sodium. Moles and moles cancel, oxygen cancel, and let's turn mole of sodium into mass of sodium by multiplying it by its molar mass. There you go. So let's 1 divided by 32 times 4 times 23 is 2.88 grams of sodium. So let's interpret this answer. That means if you're going to react all 1 grams of oxygen, you need at least 2.88 grams of sodium? Let me say that again. 1 grams of oxygen will require 2.88 grams of sodium. Am I given enough sodium? No, I'm not. I'm only given 1 grams of sodium. Right? I don't have enough sodium to react with all 1 grams of oxygen. So, yeah, sodium is limited. Okay? Sodium is definitely limited. Because if I want to react all 1 gram of this, I need 2.88 of these. I don't have that. I only have 1 gram of that. So that is limited. So my initial calculation was right. Okay? So whenever you're given both reactants, you need to find out which one is given too much. Because the one that is given too much is the one that you're not going to use to determine the product. Because you will always use the limited reagent for product determination. It's the same thing as saying you have a car. Okay, let's say you have 2 frames. That's an ugly car. You have 2 frames, and you have, I don't know, 9 wheels. Okay? Which is the determining factor of how many cars you're going to get. You're not going to determine it. You're not going to determine the amount of cars using the one that has too many wheels, right? You're going to make 2 cars. Why? Because for every 4 wheels, a car will need. You have 2 frames. Obviously, you have an extra wheel here. So the determining factor will not be the wheel, but the determining factor will be the frame. The frame in this case will be the limited. The wheel, as you can see, will be the excess. It is the limited that you're going to use to determine how many cars you're going to make. Okay? You're probably thinking, oh, well, one car has 4 wheels. You have 9 wheels. You're really only going to make 2 cars, so this is still legit. Yeah. But you know what I mean. All right. Let's erase these ugly cars. And let's finish the question here. So as I said, okay, you are going to use the limited reagent to determine products. So the limited reagent here is sodium. So 1 grams of sodium, okay, you're going to change that to moles. So this will be the same type of question we saw in the last class. So for every 4 moles of sodium, you're going to produce 2 moles of Na2O. And for every mole of Na2O, it is 62 grams. I hope I'm right, okay? Moles and moles cancel. Moles and moles cancel. Grams and grams cancel. Na and Na cancel. And you're left with grams of sodium oxide. And that will be 1 divided by 32 divided by 2 times 62. All right. Your answer is 0.97 grams. Okay? So 1 gram of this produces 0.97 grams of these. Okay? So that's exactly... Oh, wait, hold on. That makes no sense. That makes no sense. Did you see that makes no sense? You know what I did wrong? I did something wrong here. Oh my goodness. I can't believe that. Oh yeah, I actually can. This is not 32. 32 is not the molar mass of sodium. It's supposed to be 23. Right? How can you have this product having less mass than the reactant? That means you have negative of this. That makes no sense. So 1 divided by 23 divided by 2 times 62. Okay, much better. 1.35 grams of sodium oxide. Whew. Man, that gave me a little bit of a scare. So 1 grams of this produces 1.35 grams of that. What that means is that you use 0.35 grams of oxygen to make that happen. You don't need all 1 grams of oxygen. You only need 0.35 grams of oxygen to completely react all 1 grams of sodium. So that's limited and excess reagent. All right? So let's do one more example. And hopefully you guys have, I guess, this down pack. Let's change it up a little bit. Let's do another reaction. So nitrogen gas plus hydrogen gas produces ammonium. So there's 2 here, 3 here. So the ratio here is that for every mole of N2, it needs to react with 3 moles of H2 to produce 2 moles of NH3. So if I have 0.8 grams of this, and I have, let's say, 1.5 grams of this, I want to know how much of this, let's just say in grams. I can easily say moles molecules or even as silly as number of hydrogen atoms. But I just want mass of ammonia. So how much ammonia am I going to get? So as you can see, I'm given mass for both reactants. Oh, you know what would be really fun though? If I give you mass of this and moles of this, then that will be fun, eh? That will be fun. That will actually be easier if you think about it. But I am not. Not right now. Maybe in some practice questions. But yeah, I give you 0.8 of this, 1.5 gram of this. I want to know how much of this am I going to get. And don't tell me this is going to be 2.3. You're not going to add these two together and get this, are you? Oh, yeah? No, you need to find out which one is limited and which one is excess. So let's do that. Let's do just that. So 0.8 grams of N2. So 1 mole is 28 grams. I hope that I'm right. Yeah, I am right. So grams and grams cancel. For every mole of N2, you need 3 moles of H2. So moles and moles cancel. N2 and N2 cancels. Since this is a mass that I'm going to make comparisons with, I better change this to a mass. So remember, if I do give you this in moles, you can just stop here because you already have moles. Then you make the mole comparison. But since I give you this in mass, I will need to change this to mass so I can make the mass comparison. You can't compare moles with mass. That makes no sense, right? All right, here we go. So for every mole is 2 grams of hydrogen. Moles and moles cancel. So what you have here is mass of hydrogen. And what would that be? So 0.8 divided by 28 times 3 times 2. Hopefully I did this part right this time and I didn't have any mistakes. So that will be 0.17 grams of H2. Okay, so 0.8 grams of N2. So 0.8 grams of N2 will need at least 0.17 grams of H2. Whoa, look how much I was given. Look how much I am given. I'm given 1.5 grams of H2. Am I given too much? Oh yeah, I'm given way too much. Man, how generous. So what does that mean? I'm given too much H2. What does that mean for H2? H2 is therefore excess. If H2 is excess, N2 must be limited. Okay, so how do I find NH3? Well, use the limited reagent. So let's do that. 0.8 grams of N2 times 1 mole of 28 grams cancel. So for every mole of N2, you need 2 moles, or you're going to make 2 moles of NH3. Moles cancel. N2 cancels. So I'm looking for mass of NH3, right? So I need one more step. Oh my goodness. So for every mole, I'm going to make 17 grams. Okay, so moles and moles cancel. And my answer is 0.8 divided by 28 times 2 times 17. My answer is 0.97 grams of NH3. So 0.8 grams of N2 produces 0.97 grams of NH3. And what that also means is that I'm going to use 0.17 grams of H2. And it makes sense. If you think about it, it all makes sense. I have 0.8 of this, right? 0.8 of this need at least 0.17 of these, right? And I will produce 0.97 of these. Hey, wait. Do I have law of conservation of mass here? I do. Because 0.8 plus 0.17, this is too much. All I need is 0.17. is equal to 0.195, is equal to 0.97. So yeah, law of conservation of mass still applies. It's just that you're not going to add too much, right? You're not going to add all of the excess. You're just going to add what's enough to react with 0.8 of N2. Hopefully you guys are happy with this, and you guys understood exactly how limited and excess reagent works, exactly how do you determine limited and excess reagent, and most importantly, use the limited reagent to determine the product. All right. I hope you guys are good. See you next time. Bye.